afternoon, Algebra 1, Period 1, 6, and 7. All right, I got 3 problems for you today. All of these have something to do with your CFCs, okay, your check for comprehensions. Let's look at the first one. Would you all agree that the area of a rectangle is found by multiplying the length times the width? Would you agree with that? So this is how the problem will present when you have to multiply the length times the width is equal to the area. After you draw your picture, it might look something like this. All right, I want you to find the perimeter of a rectangle with an area of 143 square centimeters. The length is 2x plus 5, and the width is 3x minus 1. So what I want, final piece of data, I want the perimeter. All right, now don't get cute and tell me that it's 10x plus 8. You'll use the 10x plus 8 later. As you can see, we kind of already know the answer. But anyway, later you're going to need that. But don't stop there. Some of you are doing that. You're saying, oh, that's easy, bro. Perimeter's 10x plus 8. No. I want to know actually what it is. So how are you going to tell me that? Well, the length of a rectangle is length times width. So take the length and the width and set them equal to 143. The length times the width is equal to the area. If the area is 143, 143 is equal to 3x minus 1 times 2x plus 5. FOIL time. 6x squared plus 13x minus 5 is equal to 143, and now you're going to set it equal to 0. 6x squared plus 13x minus 148 is equal to 0. Now, you can factor that. Believe it or not, you can find factors of 6 times negative 148 that add to 13. Ooh, I don't want to do that. I'm going to use the quadratic, okay? Is it in standard form? Yes. Therefore, A is equal to 6, B is equal to 13, and C is equal to a negative 148. Now that I have decided to use the quadratic formula, and now that I've identified my A, B, and C, plug them in. Oh, I forgot the parenthesis on the end of 148. Whop one of them in there for me. All right, so x is equal to negative 13. It's the opposite of b. If b is a positive 13, now it's a negative 13. Plus or minus. Remember, you're going to get 2 answers. One of them ain't going to work because we're dealing with area. The square root. 13 squared minus 4 times a times c. I forgot my parenthesis. All divided by 2 times a. Okay, so if you plug those values in, you get this. And when you clean it all up, you get that. Now, I do not know off the top of my head what the square root of 3,721. So that's the only part of this problem I used a calculator. And I know now, after asking my calculator, the square root of 3,721 is 61. So x is now equal to negative 13 plus 61 divided by 12, or x is equal to negative 13 minus 61 divided by 12. Well, we're dealing with area. X cannot be negative, all right? So I'm only going to deal with the positive side of that. So negative 13 plus 61 is 48, and 48 divided by 12 is 4. Now that you know that x is equal to 4, now all of you smart Alex can go up here and say, okay, the perimeter is 10x plus 8. Put a 4 in there. 10 times 4 is 40, plus 8 is 48. So the perimeter is 48 centimeters, okay? 48 centimeters. That's a centimeter, okay? And please, when you do yours, boy, I'd better see some labels, okay? All right, that's the first problem I wanted to talk with you about today. So we're just going to fix there. We fixed both our problems, all right? Centimeters. Okay, now the next one we have. I give you a parabola. I give you 3 points, and I want the equation of that parabola, okay? Now, yesterday I showed you how to get the equation of that using the x-axis intercepts. Today, I'm going to show you using the vertex form because we have the vertex, people. Yesterday, I was focused on any point on the parabola. We didn't happen to use the vertex. Today, I'm actually going to use the vertex, okay? So there's vertex form. Remember, it's f of x is equal to a times x minus h quantity squared plus k. And h and k come from the coordinates of the vertex. So I plug those in. Y is equal to a times x minus 2 quantity squared plus 3. That's vertex form. If you don't remember vertex form, please look it up. All right? Now, this is where you pick a point. Pick either one of these other points. It doesn't matter which one you pick. I'm going to choose that one over there. The numbers are smaller. Okay? And I know that when y is equal to 0, x is equal to -1. So I'm going to put a 0 in for y and a -1 in for x. And when I do that, okay, and square it, I get 0 is equal to a times 9 plus 3. If I subtract 3 from both sides and divide by 9, a is equal to -1/3. Now, if I want vertex form, all I have to do is drop the -1/3 in there. Y is equal to -1/3 times the quantity x minus 2 squared plus 3. If I want standard form, now I'm going to square out that x minus 2. I'm going to multiply what's inside the parentheses by -1/3, and then I'm going to add a 3 to the end, okay? And that's what I'm going to get for standard form. Y is equal to -1/3 x squared plus 4/3 x plus 5/3, okay? So if I want vertex form, you're going to give me that. If I want standard form, you're going to give me that, okay? All right, and then finally, I have the frustrated Algebra 1 student. This time they've walked to the top of a 320-foot platform, okay? And they are going to launch at 96 feet per second an object, might be their Algebra 1 book, up. And the questions I have for you is when and how high will it hit its max, and then how long before it hits the ground, okay? So I'm going to look at the vertex. That is the when and how high will it reach its maximum value, okay? When and how high will it reach its maximum value? That's the vertex. So remember, okay? Now, to build the equation, you've got to be able to plug some data in here, all right? So let's whip down here again. The initial height is 320 feet. 96 feet per second is the initial velocity. Here's the general form of that equation that you're given in your text that I expect you to kind of know how to use. The height after some time t is equal to -16 t squared plus v sub naught t, that's your initial velocity, plus s sub naught, that's your initial height, okay? Now we're told the initial velocity is 96 feet per second, and we're told the initial height is 320 feet. So if you plug those values in, that's what you get, -16 t squared plus 96 t plus 320. Now, to find the axis of symmetry, because you need the axis of symmetry to find a vertex, okay, that'll be the when part actually. A is equal to -16 and B is equal to 96. Now this is the when part. T is now equal to -96 over 32, because remember, 2 times -16 is, okay? Anyway, I put the negative on the top, okay? Oh, let's see. There we go. All right, I forgot my negative sign. I got that in there now, okay? So T is equal to 3. So the when portion is 3 seconds. 3 seconds after I throw this object up in the air, it's going to reach its maximum height, okay? Now, what is the maximum height? Well, h sub 3, put a 3 in for t, and you clean all that mess up, and you get h sub 3 is equal to 608 feet. So the when, in 3 seconds, it will reach a maximum height of 608 feet, okay? That's the when and how high portion. Find the axis of symmetry, plug that value in, and that will give you the height. Okay, actually, it's the components of the vertex. Okay, 3, 608. Now, when will it hit the ground? Okay, well, it hits the ground. The height that when it hits the ground is 0. So h is now 0. Okay. Now, divide by -16, and once again, I'm so kind to you. I put all kinds of neat stuff that's divisible by 16. Set your a, b, and c. Put the quadratic formula to it, and t is now equal to 6 plus or minus 2 square roots of 29 all over 2, and you know that t can't be negative, so t is equal to 3 plus the square root of 29. Calculate that out, that's about 8.385 seconds. All right, I'm rushing here because I'm bumping my time limit. All right, those are 3 examples of problems that I really expect you to know how to do, so take some time, review them, go over them, and get them down pat. All right, so that's what I got for you. 3 problems. Please review them. Keep those assignments coming in. Don't let the zeros stop you. 6 academic days. We're almost done. All right. May's out.